Welcome back to our Cloud Fabric series. We have come a long way, evolving from our Phase 1 flat Layer 2 environment to the manual, robust Layer 3 underlay we built in Phase 2. Now we enter our final phase, the overlay. Think of this as the easy button for your network. Using the Meraki Dashboard, we will configure our border, spine, and leaf architecture through an intuitive GUI. Meraki will then handle the heavy lifting, automatically deploying the necessary configurations across every switch in the fabric. Let's get started and see how we transform our Layer 3 foundation into a fully functional automated overlay. In Phase 2, we established our foundation by building a fully routed underlay. We configured every port in the fabric as a routed interface and deployed OSPF to ensure total reachability. You will notice Area 1 extends north of the borders to our handoffs, a design choice necessitated by the current dashboard limitations regarding OSPF to BGP redistribution. Internally, the fabric operates in Area 0, while we assigned Area 11 through 14 to the south. While each area represents a floor switch or multiple switches per floor, now shifting to our Phase 3 topology, we move from simple reachability to true network virtualization. As shown in the Phase 3 drawing, we are introducing BGP and VXLAN to create our fabric VRFs. By leveraging the Meraki Dashboard to deploy this overlay, we will automate the complex BGP peering and NVE tunnel configurations, effectively layering our services on top of the robust routed foundation we built in the previous phase. So let's go build our overlay configurations in the Meraki Dashboard and then hit the Easy button to deploy the overlay configurations to each of the switches in the fabric. Returning to the Meraki Dashboard, you can see that we're in the switch list, but we need to get to the fabric page. So we're going to go to Organization, Menu Option, and then we're going to click on Fabric. Now that we're at the beginning fabric page, we're going to click Create Fabric button on the screen, and this will take us to the Fabric Setup form. So we're going to go ahead and fill in this form, which the first thing I'm going to do is fill in the name, which in this case I'm going to call SRE Prototype Fabric. You can name it whatever you wish to call it. Now we got to put in our BGP Autonomous System number, and this will be the number 65208, which we saw in the topology drawing. Next, we need to put in the BGP authorization key, and of course this will have to match up with other devices we're connecting with, so we need to make sure we use the right password. Next on the list is to select our network group. Our particular pod is in the Cloud Fabric pod network, which happens to only be the only one there, making it easy to select. The next thing we need to do is do the Underlay Loopback IP address pool. Now, I have a planning sheet that I keep all my addresses in, so I'm going to go ahead and flip over the address sheet right now and show you my planning sheet and find my addresses. It's always a good idea to have a planning sheet before you start building, and as we can see, my sheet says I have 255.0/24 as my address. Now here is a really important note. You need to make sure that this is big enough of a range of addresses for future leaf growth. If you have to change this address, you have to tear down the entire fabric and rebuild it from scratch to change this number. Next, we need to set the custom underlay to enabled. This basically tells the Meraki Dashboard that we're going to build the underlay manually, and it doesn't have to build an underlay, it's already done. If you allow the Meraki Dashboard to build the underlay, it will build a Layer 2 underlay which has STP everywhere, which is not scalable and not a real fabric. We built a manual Layer 3 routed underlay, and so we're going to use the custom underlay button enabled so that we tell Meraki that we're not going to build an underlay, we've already done it. Next, we will select the roles for each switch. Now we're not going to do the access switches because they're not actually really part of the fabric, so we're only going to do the border, spines, and leaves. So I'm going to just start at the top and work my way down. We'll click on the little pencil for the action button and select which role each device is going to have. So at the top we have leaf O2, I'll click the pencil, and then I will click the down arrow and select leaf. That's that simple. So we're just telling it what each switch's role is going to be in the fabric. So then you move on to the next one, and the next one is a floor switch, so we're not going to do that one. And we can see there's a few floor switches, and then we're going to scroll down to this switch, and we're going to select spine for this switch, and then click save. I'm going to go ahead and fast forward the video until I get to the end of selecting all the roles. We're now finished with the role selection, but you can notice that we have 2 borders, 2 spines, and 4 leaves. Now you know there were 5 switches for the leaf switches, but remember the first leaf was a stacked set of switches. Now that we've confirmed that we've selected all the right roles, let's scroll to the bottom and click Next. Okay, next up is our VRFs. On this page, we're going to add our VRF, but there is one called Fabric already that we could use as a default, but we're going to create a new one that is more meaningful name to our prototype pod. So I'm going to click Add VRF and add my name, SRE-Fabric, into the field here. Now, this is case sensitive, so if I do uppercases SRE and an F here, my handoff router is going to have the same case sensitivity for the VRF name for this system to actually work. Now I'll click Save on the right hand side and click Next. Next we need to add the subnets that are below the leaves. So in doing that, on this page I'm going to click Add Subnet, then I'm going to fill in this form. The first item on the form is the subnet name. In this case, I'm going to put in leaf 01 routed. Next, I'm going to copy and paste the name and paste it into the VLAN name. Next, I will put in the VLAN number in the VLAN ID, which in this case will be 200 for the time being. Let's take a look at our cheat sheet to see what address we'll put into this field. As you can see from my cheat sheet that we have network 11, 12, 13, and 14, all in VLAN 200. We're going to use 11 for this first one, obviously, and then we'll move on from there when we build the rest of the subnets. Let's take that address that we just found on the cheat sheet and put it into the interface field, 10.204.11.1/24. Next, I'll put in the DHCP server address of 10.100.0.5, which happens to be our handoff 1 switch. Next, we'll select our VRF SRE fabric that we created in the previous section. Let's look at the Anycast gateway and broadcast replication checkboxes on the lower right hand side of the form. These determine how your subnet behaves across the fabric. If neither box is checked, this is a standard routed subnet that exists only on the specific leaf switch. If the Anycast gateway box is checked, which is the default, this creates a Distributed Anycast Gateway, or DAG for short. It provides a local Layer 3 gateway and stretches the Layer 2 broadcast domain across the fabric, allowing devices on the same VLAN to communicate regardless of which leaf they are connected to. If both boxes are checked, this creates a bridged DAG. It fully extends the Layer 2 broadcast domain across the fabric, ensuring seamless, consistent Layer 2 connectivity for your devices anywhere in the network. For this subnet, I'm going to uncheck the default Anycast gateway to make this a routed subnet. Once I unchecked Anycast gateway to make this subnet into a routed subnet, I'm going to scroll down to the list below and uncheck the all button so that we have none of them selected. Then I'm going to select stack 1, which is our leaf 1. So this particular subnet's going on to leaf 1. I will now click the blue Save Subnet button, and this will take us back to the Add Subnet page. We now need to add 3 more subnets, one for leaf 2, one for leaf 3, and one for leaf 4. To save time, I'm going to stop the video and create the last 3 subnets, which are identical to this one, just that they'll have the subnet information for those subnets and not the one we just did. I will restart the video when I'm finished. As you can see, I have created the 4 main routed subnets for our 4 leaves. I now need to create a DAG1 and a DAG2 subnet. I will not create a bridge DAG, but the only difference is you would check both of the checkboxes to make a bridge DAG. And of course, I will only check the Anycast gateway checkbox to make the next 2 DAG subnets. Now let's create a DAG. I'm going to click Add Subnet again, and then I'm going to fill in the name of the subnet. In this case, the name will be routed-dag-01, pretty simple, and I'll copy that same name into the VLAN name. Next on the form is the VLAN ID, so we're going to need to get that off of our addressing table. So let's take a look here now at the address table. As you can see, I need 221 for the first DAG, and it's going to have a 21.0/24 address. So I'm going to go ahead and put 221 in, and then put in the address also into the field, which was 21.1/24. Next, we need to fill in the DHCP server address, which was 10.100.0.5. Again, that is our handoff router, our handoff switch. And then the next thing we're going to do is select our VRF, which in our case is SRE Fabric. Now from here, we need to leave the check mark of Anycast Gateway checked, because this is the one that gives us a DAG, not a bridge DAG. That would be both of them check marked. We're only leaving one check marked, which is a DAG. Let's take a quick look at our Phase 3 logical topology drawing. At the bottom of the drawing, you can see how I broke up the different types of subnets to show as many scenarios as I could with what equipment we have. If you notice, there is a routed subnet hanging off of each of the leafs, and each of these could have the same subnet address since they are in different subnets on the different leafs. Now, notice on leaf 1 and leaf 2, we have a routed DAG 1, but you do not see DAG 1 on leaf 3 or 4. Now look at leaf 1 and you see there is a DAG 2 that is not on leaf 1. DAG 2 also appears on leaf 2, 3, and 4. And although we're not going to build one in our lab, I added a bridge DAG on leaf 2, 3, and 4 just so you could see what it would look like in our drawing. So now let's go ahead and select where our DAG 1 is going to be. Scrolling down, I'll unselect all of the devices, and I'm going to select stack 1, which is leaf 1, and then I will do leaf 2 so that we have DAG 1 on both leaf 1 and leaf 2. When I'm done, I will click the blue Save Subnet button and return to the main subnet page. Now I need to create DAG 2, but to save time, I will stop the video, create DAG 2, and restart the video when I'm done. So I decided to go ahead and build the bridge DAG anyways, even though we're not going to probably test with it. So I'm going to go ahead and click the Add Subnet button, and we're going to go ahead and fill in the form as we did before. So I'm going to call this one Bridged DAG 1, and then from there I will copy that same name into the VLAN name. And then we need our VLAN ID. In this case, I'm going to do this as 231. So we'll put that in the field, and then we'll move on to our interface address, which in this case is 10.204.31.1/24. We got that out of my cheat sheet like we did before, but I'm not going to show that here to save time. Next, we're going to put in our DHCP server address, which is 10.100.0.5. Notice I also selected that bottom checkbox, which is Broadcast Replication, and Anycast Gateway, which gives us a bridge DAG. Now I'm going to select leaf 2, 3, and 4 because that's where it's going to be, and click Save. Now you notice we have a bridge DAG at the bottom of the list, plus our 4 routed and our 2 DAGs 1 and our DAG 2. I'll click Next and move on to the next section, which is our Fabric Border Routing and Configuration. Be careful here because notice that border 1 is on the right and border 2 is on the left. Let's start with border 1. I'm going to click Create Layer 3 Interface, and this is going to be our interface going to our border 1. So in here, I'm going to give it a name. In this case, I'm going to enter handoff 01 for my name because this is going to handoff 01. And then I'll look at my topology drawing to find out what VRF I'm going to be putting this in. In this case, it's going to be SRE Fabric, just like we did before. And then I'm going to put in my VLAN. Again, I'll look at my addressing table. And in this case, we're going to use number 7. Notice in the white boxes here on the Phase 2 logical topology drawing, we have a 1, 3, and 7 VLAN between border 1 and handoff 1. And we have 5 and 9 VLAN between border 1 and handoff 2. And 1, 2, and 5 on border 2 to handoff 1. And 4 and 8 between border 2 and handoff 2. Again, it helps to pre-plan everything in a chart and drawings just to make sure you get everything correct and don't misconfigure anything when you start configuring your underlay and your overlay. Now that we know where the numbers come from, let's enter 7 into the VLAN ID, and then we'll move on to the next. We're going to keep our MTU at 9100 for now. Of course, that needs to match with our upstream. And now we'll scroll down and put our interface IP address in and mask. In this case, without going to look at the address table, I'll just tell you that it's going to be 10.204.0.14/30. And of course, from there, I will click the Save button to move on to the next interface. Now let's create the interface between border 1 and handoff 2. So I'm going to click Create Layer 3 Interface again on border 1. Then I'm going to give it a name. In this case, I'm going to create handoff 2 this time. And then I'll select the same fabric as we've been selecting before, which is SRE fabric. Then I will put in VLAN number 9. I will leave the MTU at 9100, and we'll put in the interface IP of 10.204.0.18/30. I'll click the Save button, which will take us back to the interface page. And now we need to do border 2. So we're going to click on Create Layer 3 Interface on border 2 on the left-hand side here, and we're going to do the connection between border 2 and handoff 1. So we will call this one handoff 1. Once we put that information in, we will select our VRF, which is SRE fabric. Then we will put in our VLAN of number 6. We'll leave our 9100 for our MTU, and we'll put in our address of 10.204.0.6/30. Then I will click Save. Now back at the interface page, we'll click Create Layer 3 Interface again, and we enter in. This is for border 2 to handoff 2. I'm not going to narrate this one, I'll just let it go, and I'll be back with you in a second. Now we need to create our eBGP peers. We're going to do it on border 1 first, then border 2. So on the right hand side, we will click the blue button down arrow and select Create eBGP Peer. Now we're going to fill in this form. So we'll fill in our neighbor address for handoff router 1, which is 10.204.0.13. From there, we'll go ahead and put in our remote AS, which is the remote AS of where the handoff switches are at. In this case, we're in 65.207. Then we'll select our fabric, which is SRE fabric, and we'll have our source interface, which is the local one here going on the border going to the handoff 1. And then we'll put in our MD5 password, which in this case we just use the dcloud password for everything in our lab. So we're going to do that again. Now I'm going to click the I'm going to add the eGBT instance button in the upper right hand corner and add one more going to handoff 2. So I'm going to go ahead and put in the IP address or our neighbor address for handoff 2, which is .17. Then I will put in our same 65.207 for our area, and then I will do SRE fabric, and then I will select the local address or interface that's going to handoff 2, and then put in our password again. Once I put in the password, I will click Save, and that'll take us back to our page where we started this from. Now we need to do the same thing to border 2. We're going to go ahead and click Configure eBGP Peers on the border 2 side, and then we'll put in our information just like we did before. So we'll put our neighbor in, which is 10.204.0.5, which is handoff 1. We'll put in the remote area, which is 65.207. We'll select our VRF, which is SRE fabric. Now, while this is filling in, I want to say that this is case sensitive. Now, I did make a mistake and I had to go back and fix it outside of the video, but notice how I have uppercase SRE and an F in there. In the handoff switches, I have all lowercase. It would not converge. I couldn't get this to work. Turns out that it was case sensitive. So just make sure that when you do this, that everything you do in the Meraki fabric and in the underlay, you do the same thing in the handoff switches in the case sensitive portion of this. Otherwise, it won't converge here for BGP. Now you will not have to do an hour of troubleshooting like I did. Ain't that cool? Alright, so now that I'm finishing up on this eBGP configuration for the border 1 going to handoff 1 and handoff 2, I'll finish up the password, and then I will click save, returning us back to the previous page. Notice on both borders I now have 2 interfaces each and 2 eGP peers on each one of them, so I'll click next. Guess what? We're at the finish line, believe it or not. So here we can do a review of everything we built here, and then we can click save to staging. It doesn't deploy right now, we will just save it to staging, and we can review it, edit it, change it before we deploy it. Here we are at the staging page. You can see that we have our configuration here, and you can see in purple there in the middle it says staged. So we could edit it by going and clicking on the blue link where the name of the fabric is, and go in and edit all these items and put it back into staging once we've edited it. Just so you can see it, I'm going to click on it and go into the editing before we deploy it, and you can see a summary here of what's been deployed and what hasn't. We haven't deployed it yet, so there's no real numbers here yet that make it any fun. But I can click on the buttons across the top, and I can click and go through each section and edit each section, like device roles. I can edit the VRFs, I can do the border configurations, and then from here I could edit these interfaces if I needed to, whatever I need to do. Then I can go up to my fabric subnets and edit these if I want to, and then I can click on deploy. So I could click deploy here, and when I do that it's saying, hey, you're getting ready to do this, do you really want to do this? And once I decide if I do or I don't, I can either hit cancel or proceed. So I'm going to go ahead and click proceed, and then it goes into deploying mode. I'm going to go ahead and leave this on so you can see how long it actually takes. I'm not going to edit the video at all. I'm just going to do this here and I'll show you how long it takes to deploy. It's actually really quick. After all those hours of work, this just takes an unsatisfying few seconds. And bam, just like that, 30 seconds later, it is deployed. Kind of anticlimactic, isn't it? Let's continue this discussion in the next video, where we will walk through the verification process of confirming the fabric is fully operational. I look forward to seeing you in the next video. This is Paul Stryer. Have a good day.